Awesome. Oh, cool. Hey, everyone. Thank you very much for coming along. Thank you to the organizer for inviting me. It's my first time in the Netherlands. Thoroughly enjoying it so far. And yeah, I'm here today to talk a bit about testing React applications. I work for a company called Pusher. Purely out of interest, who's heard of Pusher? That's not bad. That's pretty good. So Pusher is like a hosted real-time service that makes it really easy for you to send data over WebSockets in real time. We take care of all the infrastructure and stuff, make it really easy for you to build fun things. Feel free to come chat to me about Pusher. I've also got a ton of Pusher stickers. I've seen a few people with laptops with lots of stickers on. Please come and grab me if you'd like one of those as well. My name's Jack. As I said, I blog on JavaScriptPlayground.com, which you hopefully might have come across at some point. That's amazing if you have. I'm on GitHub as well as Jack Franklin and on Twitter too. Don't forget the underscore in Twitter. Cool. So yeah, the topic I want to cover today is testing. There's kind of been a theme that's been mentioned throughout a few of the talks around confidence when writing code and how React really helps with that. And testing kind of takes that to another level. Some of the things that testing gives us as confidence in our code, if we're backed by this suite of tests that confirm that things are working as we expect. If you have a bug that you want to fix and you can write a test first that shows that bug in action, you can then fix the test, fix the bug, and then know that that bug can never come back again. It also, if you've got lots of developers working on different bits of a really large application, you can have confidence that developer A over here doesn't break someone's code all the way over here. And it's really nice for refactoring as well. So I hope I don't have to convince too many people that testing is a good thing. I'm going to focus more today on testing React. One question I get a lot, and I think Shakespeare asked it first, was TDD or not TDD? It was something along those lines. I can't remember the exact quote. So this is the practice of writing your test first. So you write the test knowing that it's not going to work, and then you write the code to pass it. I think this is more just a preference thing. I'll often write test first sometimes and not others. So I don't think it's a big deal. I don't think you're doing testing wrong if you don't write test first. That's entirely up to you how you tackle that. Cool. So before we get into React specifically, just to quickly cover, there are so many different options for testing JavaScript out there. I've picked one called Tape for this presentation. But there's Mocha, there's Jasmine, there's Jest, which is worked on by a team at Facebook. But more importantly, this talk is test framework agnostic. All the tools and kind of things I'll talk about aren't specific to this testing framework. So if you don't like Tape and you think Mocha or Jasmine would be way better, that's fine. Everything here is just, all that library is providing is the little wrapper around the actual testing itself. So please don't hate me if I've picked Tape and you don't like Tape. There's lots of options out there. Everything in this talk can be used with any of the frameworks. I put this slide in. I don't think I need it really because we've seen a lot of ES 2015 on screen so far. But I try to use a lot of ES 2015, particularly when testing. I find it tidies things up. So you'll see a lot of arrow functions, which make things easier, and a lot of imports as well, rather than requires. And the colors on that aren't fantastic, but we should be okay. So just to give you a quick example of how Tape works, this is a kind of boring old test in Tape. So we first import it, and we test. Can I laser? Yeah. We can nest using callback functions, and we give them an argument t. Then we have to tell test how many assertions we're going to make. So here I tell test Tape that we're expecting 1 in this block. The reason behind that is if you tell Tape how many you're expecting, it knows to hold off if there's an asynchronous one waiting. So Tape has really good support for async tests out of the box. And we can also use like deep equal to assert that an object is equal to another object. I really like Tape. It's pretty straightforward. It's pretty minimal. It doesn't give you as much compared to some other frameworks. And I personally like that a lot. And it's got good support for being transpiled through Babel as well, which is what we're going to do. So to do that, just very quickly, we use Babel register, install that. And then we configure our test script to just require Babel register before running our actual tests. That ensures that Babel is running all our code is converted. If you run a suite of tests through Tape, though, the output is pretty dull. Like, this is it. You should get rewarded a lot more for getting passing tests than some black text with, like, OK at the bottom. Like, I don't want OK. You did an OK job. Tape outputs a thing called TAP, which is the Test Anywhere protocol, which is basically designed for computers to read, but not humans. The idea behind Tape is that you get this output, you can pass that into lots of other things that will make it prettier. And this isn't really designed for human eyes. So one I prefer is called Faucet, so we just pipe our output through there, and hopefully this plays. So that's what it looks like with Faucet, which is much nicer and a bit cleaner. There are lots of these available. One in particular, if you were really feeling keen, you could do this. If you wanted. We do have a 9cat reporter for tape available. Yeah, and that's kind of cool. I would never like to work in a team that used it though. But anyway, so basically you can take this output and do whatever you want with it. There's lots of options. There are tape reporters that kind of mimic like RSpec in Ruby or Jasmine or Mock or whatever. So you really can take the output and do what you'd like. Okay. And I should also note quickly, I've got a link at the end to all the code that's on GitHub. All the tests I've got in this presentation and the application we'll test is all on GitHub. So I'll have links to that at the end, and I'll put the slides on Twitter once I'm finished. Okay, so moving on to React. To start testing, I needed to make an app to test on. So I went away, I thought for about 30 seconds and came up with this idea. You might have come across one of these on the internet before. Just in case you haven't, I've got a video of it. So yeah, we can delete them, we can tick them, and we can add new ones. I think it's the next unicorn. But anyway, so this is a little to-do app we're going to use to test today. Just to give you an idea of what the structure of it looks like, we have this to-dos component up here, which kind of wraps everything. Then we have a list of to-do components. They get each individual to-do and a couple of callback functions as props, which we'll look at in a minute. And then we have this add to-do component, which is just responsible for the form as well. So there's not much going on there. There's not too many components, but it's a nice kind of sized application to start writing some tests with. All the state is held in the to-dos component, and other components notify the to-dos component when data has changed. So the to-dos component is where all the state lives in here. So I said we were going on to React testing, but just before we do that, I wanted to go on a point which actually Jamis this morning set me up for brilliantly. We didn't even plan it. I genuinely had this in my slide deck before the talks this morning. Embrace plain old JavaScript objects. This is one of the reasons I love working with React. Is because it's so easy to pull stuff out and just work with libraries or just work with plain JavaScript as well. What I found here is that most of your logic, the kind of complicated logic around your state and your application, or your business logic, you might call it, should exist outside of your React components. Once they do that, suddenly testing frameworks doesn't become an issue because a lot of your core logic is just in plain JavaScript functions. And if you can make those functions pure and make them very easy to work with, they'll be very easy to test as well. So you'll see if you look on in the GitHub repo, the example application that I've got pulls out these functions which I use to manipulate the state. So I have one called toggle done. It takes the existing state and the ID of the to-do that should be toggled between done or not done. Add to-do, which takes a state and a new to-do and gives me back the new state. And delete to-do, which does exactly what you might expect. This is basically a very poor man's Redux. But you know, I didn't need Redux in this application, but still by pulling these out, they become really easy to test. Suddenly my core business logic doesn't even need any React stuff to be tested at all. I can just write a regular old test for these, no sign of React anywhere. So see here, I plan a test. I create my initial state, which is to-dos that are an array of one to-do. I've got some milk, or I've bought some milk. I compute a new state by calling this add to-do function, which is the function I'm testing, with the initial state and my new to-do. And then I assert that the second object in my to-dos array is now this new to-do that's being created. And that way all your core logic can be written entirely independently in their own tests. When you can test stuff like this without having to load up a framework or boot up whatever React, they're also much quicker too. So just by doing it this way, it's just wins all round. But I expect the real reason you're listening to this talk is probably to hear a bit about testing React components. So I should probably start to cover that at some point. So what we're going to do is look at testing a bit of our application. We're going to start with the to-do component, which is responsible for one of these bullet points here. So within this component, there's a few things you can do. The component looks somewhat like this. It's a React component, unsurprisingly. The prop types it takes is to-do, which is an object representing the to-do that will be rendered. Done change, which is the function it should call when a to-do has been toggled between done or not done. And then delete to-do, which is the function it should call when its to-do has been, the delete button has been clicked. I've put the code up here. It doesn't really matter. This is be more useful if you're looking through the slides later. But it's pretty straightforward. We just render that as a dreadful color blue. I'm sorry about that. But we just have a paragraph that has the to-do text, a button to click delete, and we can click on this paragraph to toggle it as well. And here's the toggle done, just calls done change with the ID. Delete to-do calls the prop with the ID as well. So the core kind of bits of logic in this component, which is how I always start when I'm trying to think of how to test it, by kind of writing down the logic. The div that we render, this one here, which is quite tricky to make out, gets a conditional class name of done-to-do if the to-do is marked as done, so we can style it as such. Clicking that delete button to delete a to-do should call the this.props.delete to-do method with the right ID. And clicking a to-do calls the toggle done method also with the right ID. So those are kind of the bits of functionality I want to test. So thankfully, with React, the testing story is actually really good. These used to come built in. They now come as a separate install. React ships with the TestUtils add-on, which we just install through npm. And this basically does my job for me as a presenter. I could probably walk off now and be done with it. But the TestUtils provide most of the kind of functionality we need to test our React components. So to start with, we don't even need a DOM to start testing React components. A kind of semi-experimental feature that's been in React for a while now is called shallow rendering. This is the idea that we render a component in test, but rather than rendering it as an actual DOM element, we return an object that would represent what would be rendered. So to save the overhead of actually rendering the component into a DOM and like going through a big DOM to search for whatever we need, we can just get back this object which represents what it would be like if it were rendered into the DOM. And this is just another way we can keep tests quick. If we don't have to bother setting up a DOM and tearing it down and rendering into it and checking it and searching it, the test will be a little bit quicker. They might only be quicker by a few milliseconds, but if you add that up over a big React application, that will probably save you a good amount of time in the long run, particularly if you're running these every time, every few minutes, whatever. So if I wanted to start testing my to-do component, I'd do a bit of setup first. So we import React, the component, the TestUtils, then I set up this shallow render to-do function. This will take a to-do object and return a to-do component that's been shallow rendered. So we call create renderer. I have this dummy function because the to-do component expects to be given a couple of functions, but at this point in time, I don't really care about them. We call renderer.render, and then we return renderer.getRenderOutput output to get this object back. Now, what this object looks like, just to give you an idea, is the object that the shallow renderer gets back looks somewhat like this. There are a few extra properties, but I've removed them to save space. They're kind of non-important for now. So this isn't quite accurate. I've removed a couple of bits, but this will give you a rough idea. So we get back an object, and you can see it would have rendered a div. This div would have had these properties. So there's the class name it would have been given. It has two children. It would have a paragraph with these properties, and it would have an anchor with these properties. So if you need to make tests on what's been rendered, you can do it this way and save the need for a DOM. So if I want to test, say, that the text of the to-do, so in this case for this to-do, if we want to check that this text, so this is my laser stop note, buy milk. If I wanted to test that my component renders that, I can do it by kind of digging through this object. So my first test might look somewhat like this. By the way, if you're thinking this is really verbose, it is, and later on in the slideshow, I'll kind of blow your minds with something that makes it way better. But for now, stick with me, and we're going bit by bit. So we're going to make a to-do. Its name is buy milk. I shallow render to-do, which is the function I showed you a couple of slides back. And then I just say it renders the text of the to-do, and we say result.props.children 0.props.children is buy milk. And it really rolls off the tongue, but that does assert that our tests are that our component is rendering the text buy milk. It's worth noting that I wouldn't necessarily always write tests like this and assert every bit of text my component is going to render, but it's quite a good demonstration. Then if I wanted to assert, say, that the component gets the right class, if that to-do is done or not, I can do a similar kind of thing. So I make my to-do done, and then I just check result.props.className, and the index of done to-do is greater than -1. So if you're testing basic things like custom classes or dynamic classes that change based on some state or properties, doing it through shallow rendering is a really nice way to do it without needing a DOM. But at some point, you probably want to start testing user interactions. I think we've all been through the hellhole that is like end-to-end or integration tests. We have to fire up a browser and actually pretend the user's actually clicked, and the way they break about 50% of the time. But React does this really nicely. Because React has its own synthetic layer on top of events, we never have to do that. You'll find your integration test, if you like, or your high-level test, functional test, end-to-end test, whatever you'd like to call them, and tend to be much more reliable. And you can write them more as unit tests, really, and need less of those tests that actually fire up a physical browser. One thing that's really important to note, it's really tempting when you're testing these components to reach into React components, like set a bit of state, or to reach into it to see what some state is. You should always try to avoid that whenever possible, because I tend to think of that as breaking the abstraction. The input should be your user actions, that's clicking, filling in a form, whatever it might be, and your output should be the rendered result. You should try and always avoid reaching into components to look at their internal details. Try and write your tests as if you were a user, if you like. So as I said, we need a DOM. And we could run these tests in a browser and just refresh the browser lots because the browser has a DOM. But that'd be kind of boring. I also really like having my tests in a terminal. I like having them a bit quicker. So instead, we're going to use JS DOM, which is a DOM written in Node, because of course. So what JS DOM does is it basically is a full DOM implementation that you can run in Node and will make React think it has a DOM. So we install it through npm. We do a small amount of setup. So we basically say, if we don't have a document, create one. So this is jsdom.jsdom, and I'll just use like some boring HTML, set up a few things, and then we call this function. So now any test that needs a DOM to be created just has to import this module first, and one will exist if you like. So at the top of my test file, we import that setup file, and then we import React. When React first runs, it does a bunch of checks to see if it's in a DOM environment or not. So it's important that your JS DOM setup is pulled in before React is, else React will pretend they'll think that it doesn't have a DOM. So if we take the user interaction of toggling a to-do, look at how we might do that. We now actually need to render a component into the DOM. We can't make do with shallow rendering anymore. In the future, shallow rendering may work with interactions, but right now it's much better to actually just render to the DOM. So we have testutils.render into document. So this is part of the React TestUtils add-on, which does exactly what you might think. We give it some component and it renders it. One really nice thing about this is it renders it into a detached DOM node. So no longer will you have to clean up the DOM in between your tests, which again saves you time and effort and makes it less likely that the test will break. So if I want to test that when we click on a to-do, that toggle is called, this is how I might start doing it. So if we look down here first, we have the to-do component, which takes us to do. And now I actually need to pass in the done change function, because that's the prop that this to-do component should call with the right ID when I click on that to-do. So I pass in this done callback. This done callback is way up here, and this is where the actual assertion happens. So it's going to take an ID, and I'm going to assert that that ID is equal to 1, because my to-do has an ID of 1 as well. And I've told tape at the top that we're expecting 1 to do. So now all we need to do is make the click. TestUtils makes this pretty easy with the longest method names known to man. So we call testutils.findRenderDOM component with tag. We give it the result, which is this result here, so the result of calling render into document. So we give it that, and then we give it the tag, which is a paragraph. Yeah. And then we simulate a click on it, which thankfully is much more common sense. So we call testutils.simulate.click with the text. And with that, that's it. I wish there was something more exciting to show you, but I think it's actually good that it's not that incredible. And React makes it really easy. So we have our assertion all the way up here. We render our component here. We search for something here, and we simulate the click on it here. And then when this is clicked, this done change function will be called, and this assertion will run. If that thing is never clicked, tape will actually time out, because we told it at the top we're expecting an assertion. If this never runs, it will never get an assertion, and it will error at us. However, this is a bit weird, this kind of approach. And some people don't like the way that we have actually the assertion right at the top and all the setup down below it. The ideal test should look more like this. We set it up, we interact, or we do some invocation on a function, and then we assert on the results. We've actually got it backwards. We've got an assert on the result right at the top, then we've got our setup, then we've got our invocation, or in our case, clicking. If you don't mind this, that's fine, but I've been kind of playing with a different way of doing it, which is using test doubles. And I'm a bit biased here. I've actually written my own little test double library, which I tend to use, shock horror. But there are loads of them out there, like Synon, testable.js, etc. Again, what library you use to use for your doubles doesn't matter at all. And a double kind of, and stubs, that can all get a bit confusing, but a double is basically just a function that keeps track of its calls. So if I import double from my doubler library, and I create this function x using double.function, I can call it once with React, and call it again with Amsterdam, and then I can ask x what its call count is, and it will tell me 2 because I called it twice, and I can also get an array of all the arguments that it has ever been called with. So if you only care that a function was called with the right arguments, using a double library is a really nice way to do it. So now I can swap my test round. So my done callback becomes a double, so it's a fake function, and my assertions become that it was called once, and the first time it was called, its first argument was 1, so it was called with the ID of 1. Which makes my entire test look somewhat like that, and now we're in the right way around. We're setup, interaction, and assertion. So we've got setup, interaction, and assertion. I actually like to separate them with a blank line as well in my test, but that's kind of entirely up to you. Okay, just to give you an idea of how we might do form submissions. if we look now into the add to do component, it's pretty similar in kind of style. It's a React component, and we have on new to do, which should be called with the right thing. The component looks somewhat like this. So we have this input. It's got a ref, so I can get the value at it. Really, I should like have a controlled input, excuse me, but I cheated and used a ref. So I grab the value of it. If we have one, I'll call on new to do, passing an object with a name set to that input, and then I'll clear the value out again. So first we'll render add to do. This test is probably going to be pretty similar to the last, which hopefully shouldn't surprise you too much. And I'll create a double as well so we can track its call count. Then we'll use the snappy method names to find our input and set the value to buy milk. And then I'll find the button and click the button again straight as before. And finally, we can make basically the exact same assertions. It was called, and that the arguments the first time it was called, the first one of those was the object name buy milk. And that looks like that. And you'll find as you write React tests, a lot of your tests will look like this. And I think this is a really good thing, that the React tests, they're not boring, but they're just pretty straightforward. The testing story for React is really nice. You often just do exactly what you think. That you don't have to like fake clicks or do anything. You just kind of trust React TestUtils to do all that stuff for you. So far we've tested the lower level components. So we've tested the to-do component, we've tested the add to-do component, but you probably want some like higher level tests that your entire to-dos application is rendering some to-dos. When you add a new one, it adds that to the list. When you delete one, it deletes it, and so on. And you'll often have a few components like this in your application which kind of encapsulate a bunch of states. In our case, it's the to-dos component. So these tests, although they're kind of a cross between unit and integration tests, they're a bit high level. We have those lower level tests that assert that the right functions are being called. So we have high level tests that assert that the right things get rendered or not. And I mean, that's it. It doesn't really matter what it is. That is the component. That's pretty small to read. So if we test adding a to-do from the point of view of this high level component, it's going to be pretty similar. We render now this whole to-dos component. I find the form input. I fill it in, I find the button, and I click it again. And now what assertion do we actually want to make? All we did when we tested the add new to do component was test that it would call that property function with the right value from the user input. So what we actually want to do in this test really is test that it will render the new item to the screen. So you ready for another snappily named method? Yeah, you are. We've got scry render DOM component with class. I didn't even know what this meant. When I found this, I have no idea what scry meant, and I'll tell you what it does in a minute because I tweeted it and someone told me. And then all I'll do is I'll assert that there are 4 of them shown because I've actually hard-coded the state of to-dos to have 3 in. So the result of clicking this should be that there's now a 4th one rendered. So I search for all the items in here with this specific class, and I assert that there are 4 of them. Scry renders DOM components with class, which rolls off the tongue, although I guess they were at least verbose. So scrying is like the practice of looking into a translucent ball, like a crystal ball. So I believe that's where the name comes from. I'd have just called it search or something, but there you go. Yeah, that's just me. Then again, I'm not the one clever enough to work at Facebook, so there's probably a very good reason, and I'm being a horrible person. Okay. So yeah, our full test ends up looking somewhat like that. Anyway, as you might have noticed, and I kind of hinted at it a bit, I'm not sure if you picked up on the subtle jokes, but TestUtils is pretty verbose, right? It's good, it's really good, but it's very verbose. But thankfully, I'm not the only one who thinks it's verbose. The people at Airbnb also think it's verbose, and they wrote a library called Enzyme. Enzyme is a JavaScript testing utility for React, which makes it way easier to find and assert and manipulate React components as you need to. It kind of takes a lot of inspiration from jQuery in the way it lets you find elements, and it's just so much nicer. It's like you can think of it as a layer on top of TestUtils, effectively. It's worth noting as well, just for the record, Enzyme is entirely unopinionated about which testing framework to use it with. So again, I'm using it with Tape, Mocha, Jest, Jasmine, and so on will all work absolutely fine with Enzyme. So install it like so. And what you'll find with Enzyme is it doesn't really, all it does is just make things much nicer and cleaner and give you nicer methods to call. So if we start with shallow rendering, if you remember earlier, I had to create a renderer and call like renderer.render and then renderer.getOutput to get that object. I can swap that all out for just shallow from Enzyme, which makes that much, much cleaner. Enzyme also provides, so for shallow rendering, Enzyme also provides an API for searching through that big object that was representing what would be rendered to the DOM. So if I take my test from earlier, check out this line here now. So instead of doing result.props.children square bracket 0 .props whatever that was, I can instead call result.findp.text, which I think does make a little bit more sense. There are tons of methods Enzyme gives you to search through and assert on the output. There's a link there to the documentation. Enzyme also makes it much easier to test user interactions too. It provides this mount function, which is the equivalent of TestUtils render into document, if you like. So we can import mount, and this is a bit small, but you can see up here we're calling mount with that component. I can then call form.findInput.getZero to get at the DOM element, set the value again to buy milk. I can then call form.findButton.simulate click. So again, that's just, it reads much nicer, it's much clearer what it's doing, and the tests aren't so long in line length as well, so you can work on them on a small laptop. There's full documentation there as well for Enzyme. And just as a final bonus, I've run all these tests so far in Node. So as I'm working on these tests, I'm running them in the command line. I'm a nerd, I use Vim, I've got some shortcut. They're running lots in a terminal tab, and that's great. But at some point, you probably do want to run them in a browser just to be safe, or probably in browsers. Thankfully, it's pretty straightforward to do. This is the only bit of the talk that's specific to tape, but solutions very similar to this exist for other libraries, so you should be able to use the kind of same ideas. So first thing, we're just going to bundle up all our test code. So I use Browserify. This would work just fine with Webpack or whatever else. There'll be 5 more ones by the time I've sat down. So we bundle up all our tests into a big client-side file, and we use a thing called tape run to run them in a browser. This will take our tests, fire them up in a browser of our choice, run the tests, and send the output straight back to our terminal. So all I do is I take my Browserify thing and then I pipe it through to tape run, and I tell it to run them in Chrome just as a demo. You can run it in Firefox, i.e. if it's on your machine, Safari, Opera, etc., etc. And hopefully just a final bonus video, I think. So I run them here, it fires up Chrome. Fires up Chrome, and then it runs them, and I forgot to format them nicely, but we get them all back as well. So you could swap out Chrome here for Firefox, Opera, etc. And there's my backup screenshot in case it all went wrong. Okay, so I'm on like 28 minutes. Just to give you a few links. A lot of the content from this talk comes from a blog post I wrote at Christmas for the 12 devs of Xmas.co.uk. There's a link there. I wrote this repo with all the tests. I've since, by the way, this blog post is a little bit outdated, so this repo is actually up to date as of this presentation. I pushed a bunch of stuff today. Once I've kind of sat down and taken a deep breath, I will upload the slides to SpeakerDeck, and I'm speakerdeck.com/JackFranklin. I don't know if I'll have time for questions now. Maybe I'll squeeze in one. But I'm around for the rest of the day and at the after party as well. So please come and grab me. I've got pusher stickers. That's it. I've got push stickers. Jack_Franklin on Twitter, javascriptplayroom.com. But thank you very much for listening.
Because I think after this is, I'm not going to say, otherwise you'll go away. There's time for one question.
One. Make it good. I should have said easy questions.
Well, thanks for the talk. Just a quick question. When you were running the test in the browser, does it mean that you're not running a JS DOM anymore, and you were not using the synthetic events, but the real events from the browser?
So no, JS DOM wasn't being used because in that setup file for JS DOM, I first check if like document is available as a global, so that stops JS DOM being used. It will still use React's like events layer, but yes, I believe they will happen as like real clicks. Yeah. Because it will just go in the browser.
But we're supposed to see the actual rendering? Because
no, React only it renders into a detached DOM node, so it creates a full DOM node, but it never puts it into the body for you to see.
Thanks.
No worries.
All right. Thank you very much,
thank you.
Frank.